Hi, welcome to clickmyproject.com.
Now we see the project expected ranking method for probabilistic top-key queries in wireless sensor network. Move to the abstract. A wireless sensor network consists of statically distributed autonomous sensors to monitor physical or environmental conditions. We introduce the approach of sufficient set and necessary set for distributed processing of probabilistic top-key queries in cluster-based wireless sensor network. We introduce new algorithm, namely sufficient set-based, necessary set-based and boundary-based for intra-cluster query processing with bounded rounds of communication. To enhance the ranking results, we introduced a new expect ranking method. We develop an adaptive algorithm that dynamically switches among the three proposed algorithms to minimize the transmission cost. In this project, we have to build the wireless sensor network, which is node and cluster based informations. There are two clustering based informations are provided, intra-cluster and inter-cluster. In which clustering we have to find the three methods, that is a sufficient set, necessary set and boundary based, which is used to mention the wireless sensor network in the ranking based top k queries in wireless sensor network. Now we see the data flow diagram. In data flow diagram is a symbolic representation of the flow of our project. In this data flow diagram, rectangle symbols are indicated as the status of the project. Arrow are indicate the flow of the project. Here we first construct the network in wireless sensor area. In this wireless sensor network, there are three parts are categorized, that is zone, cluster, records. In zones, we are our wireless area network are categorized into number of zones, and clusters are based on the zones, and records are based on the zones and clusters. After that, we have to find the probability and the ranking of every wireless network which is presented in this our devices. Here we have to find the node tuples, then calculate the probability. After the probability, we have to find the ranking, which is based on our aggregated probability value. After the ranking, we have to move to the expected rank method. In this method, we have to calculate the expected rank in wireless network. After that, after based on the ranking, we have to find the intra-cluster data pruning, which is sufficient set and necessary sets are presented in intra-cluster pruning. Sufficient set is based on the below of our threshold value. Necessary sets are excess value of the threshold value. After intra-cluster pruning, we have to move to the inter-cluster query processing, which is based on three algorithms: sufficient set, boundary, necessary set, boundary based analysis. After that, we have to give the expected rank of each algorithm values. Finally, we calculate the cost. Now we see the implementation of a distributed processing top-k query analysis. Here we have to select the data set which is based on our wireless sensor network. Before that, given data sets are presented to make a network. What are the nodes are presented in our data set? Click open to select the data set. Any one data sets are presented here. Here we have to split up each and data sets as a node or consider as a S1, S2 as a presented nodes, which is participated in wireless sensor network. Then zones are zone are presented on number of network are presented in our wireless network, which is categorized as a zones. Each zones has containing number of connections which are presented in zone network. Then zone and connections are presented. After that, wind guest records which is based on the each and every node IDs are presented at the zone relevant informations, and the speed of the each nodes and confidence levels and cluster are presented in the given nodes values. Now we have to move the probability values. Here we have first is tuple view, which is presented on zone level informations, and which nodes are presented on the zone are presented in tuple structure. Now you have to move the aggregated probability, which is based on the given probability values are presented on the every zone. Then possible words are presented. How many words are presented on the probability compared to our values presented in a network. After that, we have to give the top k probabilities. In this top k, each nodes are presented through the probability values of given words. In this top k values are presented calculated by the probability and confidence levels of each nodes. We have to move ranking. In this ranking, we find out the expected ranking of every nodes which is presented in our network area. In this tuple rank, we have to calculate the rank which is based on the probability value. Now we have moved to expected ranking, which is presented on double data type or a real number value. For pruning is we have to find the threshold value. This threshold value is 0.5. Now we have to pruning. The results are presented. Less than the pruning values, threshold values are omitted and set the original values as after pruning value. Here we have to find the intra-cluster values. Sufficient sets are presented. The necessary set at its expected ranking are here. Now we move to the query processing. In this query processing, we have to find the sufficient boundary values. After the sufficient values, every nodes are delivered to the base station values. Then we have to find the expected ranking, which is based on the probability, and move to the next necessary boundaries. In this necessary boundary, we have to do what are the nodes are presented in necessary boundary and deliver those nodes in the base stations. After the base stations value, we have to calculate the expected ranking. Then boundary based, which is inter-cluster values. Boundary based is average of necessary set and sufficient set values. Now we have to collect the boundaries. Each of boundaries are present delivered to the base station. Necessary and sufficient sets are combined to the overall boundary values which is presented in our wireless sensor network. Then we have to calculate the base stations, which is broadcasted to the cluster heads. Now which is presented on the number of necessary boundary and sufficient boundary. After we have to put the expected ranking. These orders will be changed. After calculating the expected ranking, top k results are presented. Now we have to move the cost model. In this cost model, we have to find the number of times are needed to find the results of the result. Sufficient set boundary values cost is 6. In necessary set boundaries, there are two phases are available. First phases are only the required confidential levels. After the second phases are expected ranking level. Base boundary values cost are presented at rupees 11, which is presented possible through the cost of sufficient and necessary set values. Thank you for watching.